And that's kind of an overview of what we're going to be looking at. So we're going to first go into, after this introduction, we'll go into some information on clustered indexes and heaps. We're going to talk about the qualities of a good clustered index, and then we're going to look at some clustering index patterns before we wrap up. And these patterns are just different ways that you can implement clustered indexing, what's good and bad about them, and what effect that they have on execution plans, and why you choose one over the other. And so as far as our goals go for today, we're going to define basically clustered indexes, explain those rules like I already mentioned, and then we'll do some demos, and hopefully this is what you're going to get out of it is these three items. So let's get rolling right into this and get into looking at clustered indexes and comparing them to heaps and just the clustered index itself. Now I mentioned that we're focusing on choosing a clustered index, but there is an alternative to choosing it, and that's not choosing it. And that's where the heap structure comes out. By default, if you just create a table and you don't put any physical structure onto how the data is going to be stored, SQL Server is going to store it in what's called a heap structure. The heap structure it's unordered. The first record that you put into it is going to be the first record that's in there. And it doesn't matter anything about numbers or alphabetation of the data. I think I just made up a word. It's basically the data just goes in there. There's no way to say where one row is versus another row besides just going in and scanning across everything to find out where that one row is. And so with heap structures, things get very, what I call, scan happy. If you don't have auxiliary indexes that are assisting the heap structure to find rows, it's going to just scan the entire table every single time. And generally that works okay for very small, tiny tables, but not for larger tables. And so there's quite a few compelling reasons not to use heaps. And just to kind of reiterate how this is unsorted, if we've got a number of pages, and let's just pretend for a moment that all of our rows map to a single page. Every row is 8K, and so it's going to fit on a single page. And if we get all of these rows, the way in which SQL Server is going to store these is, if you've got Alan and Ryan and Sarah, Madison, Joey, and Jane, Zoe and Jane all coming in. With a heap structure, the way in which SQL Server is going to organize these as they come in is storing them as they come in. And so what SQL Server will do is it'll allocate an index allocation map page in the first row that gets added in, and in this case we'll say it's Madison. Madison will be the first one placed within the table. And then it'll go to Ryan, and then Zoe if they were inserted in that order. And if that allocation map is filled out, maybe another allocation map may be allocated out. And then Sarah and Alan and Jane will be allocated out to it. And that's basically how heaps are structured within SQL Server. And so if you go and you ask for Zoe, SQL Server has no information based on heap to know where Zoe is going to be. And so in order to check for Zoe, every single page has to be checked to see if the row for Zoe is stored on that page. And hopefully in the way that I've described it, you get that understanding that there is no way to know exactly where a page is going to be if there is only one page or one row that has that information. And so that's kind of the downside to the heap. Now, the alternative is to choose a clustered index. And the clustered index is basically, it's a mechanism for storing the data within SQL Server. It enforces an order onto your data in such a way that certain rows will appear in certain orders, and you can then pull through SQL Server to figure out exactly where rows are. And it's often that you want to store your rows based upon whatever value is or information that you use to primarily pull the data out of that table. If you're pulling out data based upon name, then you might actually, if name is like the most frequent way, you may actually cluster on name. If you've got a sales table and you're pulling out by sales orders, well, then sales order ID makes sense for your clustered index. It's generally geared to pulling out by what's the most frequently leveraged item. And so in this case, if we've got, in this case, our Zoe and Ryan and Sarah pages, and if that is what we're keying off of, those pages would actually be stored physically within SQL Server based upon those values. Now, I'm oversimplifying things here because SQL Server logically stores these in physical order, but it won't always, logically stores them in order, but it won't always physically. You can have rows that appear within a page that are not stored in order, but from a logical perspective, when SQL Server is accessing the index allocation map and then the root page for the index, and then going down and grabbing the Al and the Jane, it can be that physically they may be a little bit out of order, but logically SQL Server knows the order in which records are stored and can go directly to the Sarah page. It doesn't have to check all the other pages to verify where that information is stored. It can go just directly to where that's at.